Hello everyone, today is 2022 August 27 and today's problem is balanced binary tree. The problem description is given a binary tree, determine if it is height balanced. For this problem, the height balanced binary tree is defined as a binary tree in which the left and the right subtrees of each node differ in height by no more than 1. Example, that's the tree and we could see left or right sub subtrees height is 2 and 1, so they differ no more than 1. This is bigger, this is 3, and this side right subtree is 1, so that's false, return false. Okay, let's concentrate for the numbers, nodes of tree, and the nodes value. Okay, on the very beginning, I have ideas, so since that required every node in the tree, so we need a traversal all the trees. So in that case, I'm thinking maybe I could write out all the head of each node, and then we could search each node and compare. That's the one. But in that case, we need searching from bottom to the top. And in that case, there will be recursive method for that one. And as my original idea, I will write down or record all the subtree height in each node. But as my further analyze I mean, the algorithm, I don't have to traversal all the trees until the tree is true. I mean the balance binary tree is true. In the false, we maybe return any middle step to do the comparison of each subtrees. That's the one. And to store the head in the node, since the library of the binary trees, we don't use the value in the trees. I mean, that means the node values. We could overwrite the value of node as the head of that tree. So in that case, we save the space. And I don't see any requirement we cannot modify the tree value, so I think that will work. Okay, that's the analyze I have. And next step, I'm going to do the coding. Okay, same way, I'm going to switch to the web. Okay, create a new file. They call that balanced binary tree. Okay, I need basically the function for the recursive calling. So, okay, that will return height. Okay, I'm thinking how I could interrupt the trees once. Return minus things. Since the head would be greater than or equal 0 for the head, actual height of a tree. So I define another value -1 for the false binary tree return. Okay, so in that case, we just get balance and height. Balance and height. A is balanced. O height. Okay, same things. I'm going to struct tree no root and okay. Thinking how I could handle the none. So that should be okay. In that case, now is not none. So we will handle the none. If root return 0. Okay. Okay. And let me define the left height and the right height for the initialization. I would like using the -2 for the 1. So if then left height equals is left, okay. If left height equals -1, just return -1. Else right height equals root right. Okay, so same things. If the right height equals -1, we return minus as well. If left, we just call ABS for the absolute value, and since we don't know, in this case, finally we need return the height of this tree, so we need to tell which one is higher. Okay, if right height greater equal than left. Height if right height minus left if right height greater than left plus 1, then we return minus 1 for the false. Okay, else. Yes, else return height else if left maybe that's I could do the similar logic as the above, but I maybe could do simple ABS as right height minus right height and greater than 1. In that case, we just return minus 1. Okay? And in that case, we just return else. Return right greater left return right left. Yeah, that's more clearer for that. So we do left, we do right, and we do the graters. Yeah, that's it. Okay. So I'm going to handle the root node for that. So for the root node, we don't need to do this. We just check. Oh. I'm thinking I could. It seems I have to do the similar logic in the top wrapper function call is to handle the root left or right. But I'm thinking, is there any easy way? Oh yeah. So I could directly call this one. I don't need to handle the top root in the isBalance function. I just tell it's return minus 1, that's false. If return the value greater than 0, then yeah, that will choose. Okay, that's simple. Okay, so just return minus 2, then return equals root. okay? If return equals the 1 minus 1, we just return false. Else return true. Yeah, that's simple. Okay, that looks good. Let me check the logic right here. First one, recursive. In the recursive, as my original design, I need overwrite node for the head, but seems no, I don't need it. So I just check. I combine this function, the return, value with two different cases. First one will be the head of the tree. If the tree is not balanced, I just return -1 as the indicator to break the whole comparisons there. After that, in the mini wrapper function, I just call this one, check the manner, the return is -1, return false. Otherwise, it's the head of the whole trees. That means that's already got compiled. So I just return true. Okay, since I got the code very quick, so I just run the code on Leetcode and see how it's going on. Okay, I'm going to run the code, see the result. Okay, that looks good. Submit. That's false. That's false. Let me see what's the problem. Okay. Okay, so on the very beginning, I will do this and this, left and right. I do this, right? So, and I do this, and do this. This is true, and this is true. Then this is false. Okay. Let me print something for this example. Okay, I just print two left and height and point out the root address to make sure I know the recursive calling. So run the node, see how we could get. Okay, 0, 0. Okay, that's the one. Okay, that's 0, 0. First one 0, 0, that's fine. And the left is 0. And the left is all the time is left. Why I don't? Oh, sorry. That's a print failure. Why that's always 0? Hold on. If root is none, we just return 0. That's fine. And okay, that's we check the. Okay, that's the first one is 0. 0 means let me open a 1. Okay, we will do 1, 2, 2, 3, 3, none, and 4. Okay, 1, 2, 2. Hold on, why there's 0? That's 3? Oh, that's 3, 3, 3, 3, 3, 3, 3. 3, 3, and 4, 4. Okay, so as a call sequence, I call left and left and left. Okay, this is left. So, and his left is 0, that's none. Okay, that's further on, and right is none. Okay, so this one will be 0, 0 plus 1. Oh, I need plus 1. Then always 0. Okay, that's wrong one. Hold on. So, return. Okay, that looks good so far. So let me comment out. Let me submit first. Okay, accepted. Okay, that's the major one. Okay, let me do submit and see what's the performance. Okay, temp complex. Uh, the worst case will be the traversal of a tree. That's N. Yeah, that's N. That's the big O N. That's will the that's will the worst case. The best case is really depends on the balance case will be the constant for the one. So I got beat 57, 58. That's pretty good one for me so far. Beat 58 on August 27th, 2022. Okay. Okay, here the one I think to summarize what I did. So let me see. I didn't do anything. Just to make sure I got the correct head with the +1, since that's only the sub trees plus the current root, that will be +1 always. And all these things are the same. Okay. Yeah, that's all for today. Thank you for watching. See you next time.